Welcome to another video from AskMath.com. Let's read the directions to this problem. How many solutions does the system of equations have, given y equals 3x minus 4 and y equals 3x plus 1? This question is asking us about a system of equations. And remember that a system of equations just means that you have two or more equations, in this case two, and that's called a system. When it asks how many solutions does it have, that means it's asking us if we were to graph these two equations, at how many points would they cross? And remember, there's only three possibilities. One possibility is that they are parallel lines, and those would never cross, and that would be zero solutions. Another possibility is that they are straight lines that cross exactly once, and that's one solution. And the third possibility is that one line falls exactly on top of the other line, and that's infinite solutions. So remember, there are only three possible answers to this question: how many solutions? So we're not being asked what is the solution, in other words, what are the values of x and y coordinates at this point where they cross. We're just being asked how many solutions, and the possible answers are 0, 1, or infinite. Okay, so one way to solve this problem is to actually graph it, if you have some graph paper handy. Another way is to use substitution method, and the third way is to use combination method. Combination method works very well when the x's and the y's and the numbers are lined up in both equations when you have your equal signs lined up, which we have here. Substitution works well when you have a variable all by itself on one side of the equation, like we have here, y equals, and also here, y equals. So you really have your choice here. Graphing is an okay option if you happen to have a graph, especially when the numbers are relatively small and they're whole numbers, not decimals or fractions. That is an option. I'm going to actually choose the substitution method here, and then we'll also graph it just to visualize and see what that answer looks like on a graph. So substitution, remember, just means that you take the stuff on the opposite side of the equation as the variable, so y equals this stuff, and you substitute it into the other equation, so in this case y equals 3x plus 1, for the variable y in this case. So using parentheses, that's the y equals 3x plus 1. I'm going to substitute the stuff that I know y is in this other equation in for y in the second equation. Okay, and so now we need to simplify this because there are x's in more than one place and numbers in more than one place, all by themselves in expressions. So to do that, we're going to need to collect our variables on one side of the equation, which means that this 3x here, if we want to get rid of it so that it's not on this side anymore, we subtract it. Whatever you do to one side of the equation, you have to do to the other. And so the result of that is that this makes 0, and that was our goal, so that we don't have x's on the right side. We're left with a positive 1. And since there's nothing on the outside of these parentheses getting multiplied, just that invisible 1, right? 1 times this stuff doesn't change what it is, so I don't really need the parentheses. So this is just a positive 3x minus 4, and I'm subtracting 3x, so positive 3x and negative 3x make 0 as well, and so those x's are gone, and I'm left with negative 4. Don't forget the negative goes with the term to the right. So what ended up happening is I used substitution to get rid of the y variables, and then I collected my x's on one side of the equation, or I tried to, and they all disappeared. And I'm left with this weird looking statement that has one number that it says it's equal to this other number, and that's clearly a false statement. And anytime you end up with a result when you attempt to solve a system of equations and you don't actually end up with an x or a y left at the end, there's one of two possible results that you can see. You can either see a false result like this, or you can see a true result So for example, if this had said -4 equals -4, that would have been a true result. But we didn't get a true result here. We got a false result. And a false result means that there are 0 solutions. False means it's not possible. So how many solutions does it have? Not possible, false. And so that means 0. 0 is how many solutions it has. Okay, so let's just write that here so that we remember. And this would be if you had solved and gotten an xy. And then this one, as I mentioned, and in another problem we'll get to see that, is you would have gotten a true statement here, like -4 equals -4, or 1 equals 1, or something like that. That would have indicated that it was infinite solutions. But in this case we got false. Okay, so now let's switch over to the graph, and let's just take a look and see how this would look. Okay. So let's draw an x and y axis on our grid here. And let's put it right about here. Okay, so that'll be our y-axis. And let's put our x-axis right about here. I'll just make it a little thicker so that we can see it. Okay. So remember when we learned to graph equations, if the equations are in this y equals mx, which just means some number, which is the slope, times x, plus b, which is the y-intercept, you can quite quickly graph this, and that's one reason why these particular equations, it's pretty nice to be able to graph these because they're fairly easy to graph. So on the top one, we start with the b value, the y-intercept, and that y-intercept value is -4. So I don't know if we'll be able to see this very clearly. Way down here at the bottom, and from there we have a slope of +3. Remember, that's +3 over 1. There's that divided by invisible 1 under the 3 there. So that means that we go from this y-intercept, we go up 1, 2, 3, that's the rise, over to the right 1. So +3 over +1, that's up and to the right. Up is positive, right is positive. And this is where the next point would be for this line here that the first equation gives us. So if we connect that, and that line would of course continue. Okay, and then the other equation crosses the y-axis at +1, way up there, and it also has a slope of +3 over 1, which means that we can either go up 3 and right 1, or we can go down 3 and left 1, which would be -3 over -1, which is the same as +3 over +1, since two negatives divided make a positive. So we'd go 1, 2, 3 down, 1 to the left, and those would be connected. Okay, and now it might be a little tough to see, but these lines, those are parallel lines. And so they will continue to each go up 3 and right 1 and up 3 and right 1, or if you go the other direction, down 3 and left 1, down 3 and left 1, and they'll never cross. And so you can now see that those are parallel lines, and that is what it means when you get a false answer when you try to solve a system of equations that has parallel lines. All right, that's it for this problem. Thanks very much for watching another video from AskMath.com. Make sure to check out all the other videos on the site. Take care.